Alright guys, we are recording, just recording over there, okay? So, we have 2 plus I, draw it on the diagram. 2 across, 1 up. 2 plus I is effectively the point 2, 1. Everybody happy with that? Next thing he asked me is to do 2iz. That means 2I multiplied by whatever z is. Z is 2 plus I. 2 by 2I is 4I. 2I by I is 2I squared. But 2I squared is minus 2. So it's minus 2 plus 4I, which is equivalent to minus 2, 4. That point there, minus 2, 4. Which is minus 2 up, minus 2 across and 4 up, which is effectively there. Now, the next thing you're going to be asked is find the value of the modulus of 2iz. Can anybody tell me, what do these 2 vertical lines mean? Find its distance from the origin. You're basically being asked to find the length of that line there. Alright? So you can do it 2 ways. You could use Pythagoras' theorem, couldn't you? You could say that's, if you forgot it in an exam, you could say that's 4 blocks up, that's 2 blocks across. And you can say that the length is x, and you can say x squared equals 4 squared plus 2 squared, x squared equals 20, x equals the square root of 20, which is 2 root 5. Now, I didn't teach us that way. What I asked you guys to do is to remember a formula, didn't I? Did we remember the formula I asked you to remember? Real part squared plus imaginary part squared. Okay? So what's the real part of 2iz? Where is 2iz again? That's 2iz there, isn't it? So minus 2 is the real point, the real part squared, the imaginary part squared, and long and behold you get root 20, which is exactly the same thing we had over here, and you get 2 root 5. So what I'm basically trying to explain there is that that formula and Pythagoras' theorem, they actually give you the same answer. You're finding the distance from the point back to the origin. Alright, I'm going to stop myself. And now, we're going to do the next one, which is, I also have to find out, I found out what 2iz was, that's grand, but what I also need to find out is what is the modulus of z. So the modulus of z, guys, is what? What is z?
2 squared.
It's 2 squared plus 1 squared, which is root 5. The first one's 2 root 5, the second one is root 5. What does that tell you? One of them is twice as big as the other one. Would you agree that the line to the left is twice as long as the line on the right? You can measure it with a ruler and just confirm your answer if you want. Okay. Now, what we're going to do next is, it goes, what does your answer tell me about the relative position of z and 2iz? What can we say there? That
the distance from the origin.
exactly 2iz, this one here, is twice the distance from the origin when compared with z. Basically, multiplying by 2 caused it to double its distance. What was the effect of multiplying by the I? What does the I do? And remember, multiply by a complex number by I? It rotates 90 degrees. Multiplying by I always rotates by 90 degrees. Multiplying by 2i rotates by 90 and doubles the length. Multiplying by 3i increases it by 3 times and rotates by 90. What would 3i squared do? I squared?
Increases it 3 times and makes it a 180.
A 180. So 180, if this is multiplied by 3i squared, it would go all the way around here, and then it would double out the other side to here. See what I mean? A 180 and, oh sorry, triple the distance. Sorry, triple the distance. Okay? So just to hit that home. Okay guys, conjugates. Okay, we sort of forgot what a conjugate is. Set is what guys? 2 plus I, agree with that? What's set bar? The conjugate?
Minus 2.
You only,
minus 1.
yeah, you only change the complex part, not the real part.
Yeah.
Alright? Now, do exactly what I asked you to do. What's 5 times the conjugate? 5 times that. 10 minus 5i. And then on the bottom? 2 plus I. Okay, we have a fraction. And in the fraction, there's a complex number on the bottom. What is the way you get rid of complex fractions? Top and bottom. Liam, why did you have to multiply top and bottom? Huh?
To get rid of the conjugate bottom.
Yeah, and the other thing is, when you multiply a fraction by the same number top and bottom,
It keeps it the same.
it's the same fraction, but you're essentially multiplying by 1. They can just cancel each other back out and become the number 1. 1 times anything remains the same. Everybody right with that? So, multiply it out. 20 minus 10i minus another 10i minus 5i squared, anybody? Plus 5. And then on the bottom, 2 with 2, 4, minus 2i plus 2i minus I squared, plus 1. Okay. 20 plus 5, 25, minus 20i, and then underneath, the 2i's cancelled, aren't they? 5 on the bottom. Now, what way do fractions work when there's a denominator and there's 2 parts on the top? Not flip them, split them, sorry. So it's basically 25 over 5 minus 20i over 5. You can split them or join them. Okay? And then you get 5 minus 4i. How many people got 25 for that? Anybody got 25? Right, pretty good. How many just got over 20? So yeah, that's it. So the majority of the class got over 20 in that one, so that was a strong question. Okay, we move on. We're going to video later, right? Yeah.
Yes. Keep going, sir.
Alright, this one, I'll come back later. Not really, it's got to catch it there, it'll stop and bend and all that. Alright guys, 340 as prime factors. Now, there's 2 ways of doing this. The first way of doing it is like this. You get 340. Prime factors means prime numbers. 2, 3, 5, 7, 11, 13, 17, 19, okay? Now, what you do is you pick any 2 numbers that will divide into 340. You can do 34 by 10. You also could have done maybe 220 by 17 maybe. Would that have worked? Let's see what happens here. What can you break up 34 into? 2 by 17. What can you break up 10 into? 2 by 5. How many 2's do we have?
2.
So that's 2 squared multiplied by 5 multiplied by 17. What about this one here then, the 20 by 17? Break up 20 into 4 by 5. What's the 2 break out? Just the 4 break into? What can you break 4 into? 2 and 2. And we effectively get the same answer. No matter what way we broke it down, we get the same answer. Yes, Cameron?
So you just have to use any prime numbers from them.
Yeah. Or, lazy way out. 340. Shift. Fact. same job. Yes?
I did 19 by 17 plus 17. Not
So keyword is product. Product means you have to use multiply, not pluses or minuses. It was sum of you'd use addition, but when the word, does everybody get that? Keyword is product. Product means they all got to be multiplied by each other. Go with that? Okay. Now, rational versus irrational numbers, okay? Right, each of the irrational numbers, or so put a tick first, right? 0.25 rational or irrational? Rational, because when I put it into the calculator, it comes up as a fraction. Now, if I do 5 pi over 4, does it come up as a regular fraction? As in, does it get rid of the pi? There's no pattern in the decimal either, is there? So that would mean irrational. Root 2? Irrational. There's no pattern in the decimal. Once again, root 2? No repetitive pattern. 1.3 with a dot above it. What's the dot mean? Okay. Anybody know what is 0.333? What fraction is 0.3333?
1/3.
It's a third, isn't it? So that's effectively 1 and a third. If you want to check it out, shift ABA 1 over 1 and 1/3, 4 over 3, 1 and 3 with the dot above it, 1.33333. Repetitive pattern means it's rational. Now this one got a lot of people. 12.5%. What does 5% mean? What does 5% mean? If you got 5% in the test, what does that mean? Out of every 100 questions you get, 5 of them correct. So what does 12.5%, 12.5% mean? It means 12.5 divided by 100, which you'll find out is an 8, which means it's rational. Now, it wants me to write the rational numbers as fractions. So that wants a quarter, this one wants to be 4 over 3, and this one here wants to be an 8. For the irrational numbers, it wants me to write them correct 2 decimal places, not 3 decimal places, 2 decimal places. So 5 pi divided by 4. Ah. 3.93, yeah. Root 2 is 1.414, is it? So 1.4, 1. Is that it?
Yeah.
Okay. Move on?
Yeah.
Okay. Now, really big number. Break that really big number into scientific notation. Okay. What you do is this. You put a decimal point right beside the last number. Do you see that? So it's going to be something like 2.99 multiplied by 10 to the power of something. How do you figure out how many 10s you need? And if you happen to forget that in an exam. 299, 792, 548. Just keep dividing by 10. Once, twice, 3 times, 4 times, 5 times, 6 times, 7 times, 8 times. It takes 8 of them to get to 2.99. That means 10 to the power of 8. Now, see one significant figure. Yeah? See the word significant figure?
Yes.
Let me explain what that means, alright? Significant figures are like this. If I said 4,500, how many significant figures are there? 2. The 4 and the 5 at the front are considered significant. If I said 5,000, how many significant figures are there now? Anybody know how many? 1. 1 significant figure. Now I'm going to change this up a little bit. If I said 5,001, how many significant figures are there now? 4. the zeros are in a sandwich in between two significant numbers, they too then become significant. Zeros at the end don't count at the moment, right? Now, if I did this, 5010, how many significant figures this time? 3. 501, but the 0 at the end is not considered significant. Now I'm going to dive into decimals, which is okay. So decimals, okay. How many significant figures here? It's considered to be 1, because it's all zeros before the first number has tells you anything about it. Okay. Now, how many significant figures this time? 3, because the 0 is sandwiched in. Okay. And then finally, how many significant figures this time? 4. Okay, round it up. How many significant figures this time? 1. And it wants 1 significant figure, which will turn that into 3 multiplied by 10 to the power of 8. Yes?
But what if it's like 20.003?
20.003. Okay, that is currently 1, 2, 3, 4, 5. That's 6 significant figures. And to turn it into 1 significant figure, it'll just be 20.
So you prioritize.
Okay, cool. It still has to be roughly the same value. Yeah, it comes to say 0.03. It was 20 miles away from 0.03 on it. So, everybody getting this?
What was the answer to that question?
3 by 10 to the power of 8. And if you don't remember science mode, 299792458.
I thought it was 1.
Shift, setup, science mode, science 0, and it does it for you. Right? But to get out of that, then shift, setup, normal 1.
And the always round up. On the left there, the 2.99.
Well, 2.99 is only going one way, isn't it?
Yeah, but if you put in the full number, would you be grand?
No, 1 significant figure. This here, Lee, is 3 significant figures, and this here is 1 significant figure.
Fair.
Everybody right? Now, solve this inequality. Before I solve this inequality, I need to bring you back to some of the rules we had, alright? So, let's start off really easy. Declan, what's element n?
The natural numbers.
Which starts at 1, 2, 3, all the way up. You have to put dots on them. Why do you have to put dots on them?
It's not decimals.
No fractions, no decimals. If it's element z, what happens? You can have 0, you can have -1 and -2. Are you allowed decimals or fractions? No. So once again, full dots, and there's gaps in between numbers. And then finally, element or. Everything. And in cases like that, you shade it. Everybody right with that?
Yeah.
Now, general rules of inequalities that I need you to understand is this, right? If I have 10 is bigger than 9, what happens when I multiply both sides by 2? No, both sides by 2. 20 is bigger than? Stays the same, doesn't it? Divide both sides by a number, 2. It just goes back the way it's, and you haven't had to change it at all, have you? So the only time we have to change it is when we multiply by a minus number. What happens when I multiply both sides by minus? -10 is bigger than -9. Is that true or false? False. So I forgot to switch. Okay? That is the only thing you got to remember, is the minus rule. Multiply by minus, switch your signs. So look what happens here. It's basically like a normal linear equation, except 4x plus 4 greater than 7x minus 14 plus 3. Tidy up, 4x plus 14 greater than 7x minus 11. Bring the x to the left, numbers to the right, yeah? So 4x minus 7x greater than minus 11 minus 14. Okay? Just want to double check I didn't make a mistake thus far. It's a 4, not a 14. So I knew something was a miss there. It's more like it. Now, 4x minus 7x minus 3x greater than minus 15. Multiply both sides by. What happens to the sign? And then divide by 3. X is less than or equal to 5. X elements, or is the 5 included or not included? It's included. And what happens when it's included? Full dot or hollow dot? Full dot means the 5 is included and it continues on forever because it's all numbers. If that said less than 5, what would happen? If that's just less than 5, what would happen? Anybody? It would be a hollow dot. Everybody got it? But because it's less than or equal to it, it's a full dot. Good? How many people got full marks on that one? I think it's 10 followed by a 5 more than likely, or something like that, or 2 5s. Alright, good. So most of you. Now, this one. Do you know when you're doing a solved question, what's the only way you can end? What's the different ways you can end a solved question? And give me an example of how a solved question can end. It can end with a linear equation. Do you know what I mean by a linear equation? It can end like this, where you get 2x equals 2 plus 8, which is 10, x equals 5. It can end on a linear equation. What else can it end on? It could end up on a quadratic equation. Something like that. So that'd be a minus 4. Something like that. It could end up on the difference of 2 squares. How else can it end? It could end up as x squared minus 4x equals 0, where you'd have to do x into x minus 4 equals 0, and you get x equals 0, x minus 4 equals 0, x equals 4. When it says 2 decimal places, what does that suggest? It does suggest the minus b formula. So before this question even begins, what are we expecting? We're expecting to end with a quadratic that requires the minus b formula. And how do we know that? Only by seeing that little part there. Solve decimal places. Minus b formula. If I do not get a minus b formula, this is gone pear-shaped. Okay? So, here we go, guys. Common denominator, yeah? Common denominator. So 3 divided by 2x plus 1 minus 1 bracket 3x plus 2 equals 2. Now, what does the 2x plus 1 want? What denominator does it not have?
3x plus 2.
It doesn't have the 3x plus 2. So we put a 3x plus 2 top and bottom. What does the 3x plus 2 want? It wants a 2x plus 1 top and bottom. Now, what about the other one, the other side? It wants both. So it wants 2x plus 1 and a 3x plus 2. What is allowed to happen now? Why are the bottoms allowed to cancel in this particular situation? It's the same on both sides. As an example, if I said 10 over 7 equals x over 7, what would you tell me x is?
10.
Because the 7s are the same, So for the process of solving the equation, the 7s are irrelevant. It's the numerators that makes it equal, not the denominators. Everybody got that? Numerators balances it. Okay? So effectively the balance comes down to the numerators, not the denominators. That's when the denominators can disappear. What do we have now? 9x plus 6. Here's the tricky part. Is it 1 multiplied by 2x? What is it? It's minus 1 multiplied by 2x. And that's what gets people. Now, up here guys, I'm going to do a quick shortcut. Do I multiply the 2 by both brackets or just 1? Okay, let's think about this. What's 2 multiplied by 3 multiplied by 4? What's the answer for 2 multiplied by 3 multiplied by 4? Should be given the answer for that. 2 multiplied by 3 multiplied by 4. The answer is 24. The reason being is you multiply the 2 by the 3 first to get 6, and then 6 multiplies by the 4 to get 24. Or you multiply the 3 by the 4 first to get 12, then multiply 12 by 2 to get 24. Pick 2 of them at a time, get the answer, multiply by the third one. Cameron?
You multiply the 2 brackets and then multiply that by 2.
You can. Whatever you want. I'm going to do it this way because I'm just going to do 4x plus 2. Do you understand what I did there? 2 times the first bracket. Then I'm going to multiply by the second bracket, which is going to get me 12x squared, 8x, 6x, and 4. Everybody right with that? Now, nearly there. Tidy up. I'm going to get 7x plus 5 equals 12x squared plus 14x plus 4. Bring everything over one side. 12x squared, 14x take away 7x is plus 7x. 4 minus 5 minus 1. The 0 was over here. But what can I do? I can put the 0 over here, can't I? It's like me saying 2 plus 5 equals 7. 7 equals 2 plus 5. It doesn't matter which way it's presented. Okay? Now, minus b formula to end this off. A equals 12, b equals 7, c equals minus 1. Minus 7 plus or minus the square root of b squared. Minus 4 times a times c, 4 times 12 times minus 1, all over 2 times 24, or so 2 times 12. Now, you can do it all in one swoop if you want. You can sort of do it like this. Minus 7 plus, do the plus answer first. 7 squared minus 4 times 12 minus 1 all over 2 times 12. Your first answer is going to be 0.12. Is that right with you? 0.12. And your second answer, which is the minus not the plus, is going to be minus 0.7. Who got that out? Anybody got it out? Sparrow, good job. Alright guys, that's it.